An aggressive plant pathogen called Xylella Fastidiosa was detected by scientists in Europe in 2013. It was the first time it had been discovered on this continent. Before then, it had only been found in the Americas, but now the pathogen was also killing olive trees in Apulia in southern Italy, also threatening other crops all over Europe.
We were shocked when the first time we diagnosed the presence of Xylella Fastidiosa in our diseased olive trees. We knew that this pest causes severe damages on grapevines in California and on citrus in Brazil, but we knew very little about how Xylella could attack plants in Europe, and even less on its potential impact on olives. So we had to build everything from new research program to gather knowledge on how to manage this pest in our region and in Europe.
Since 2013, the pathogen has been detected on different types of crops in areas located in France, Spain and Portugal. In 2015, the European Union issued a first set of measures to stop the pathogen from spreading further. In Apulia, where olive trees have an economic and cultural value, fake news stories started proliferating on the web and in different mainstream media, and the related conspiracy theories led to protests. Xylella Fastidiosa is the first plant bacterium to have gone viral on the media.
It was overwhelming. Scientists were even blamed to spread the pathogen. So we had to tackle all of this and explain people the risks posed by this exotic pathogen and what was at the stake in economic and cultural terms.
While scientists organised meetings with the population to debunk all the fake news that was swirling around, in 2014 and 2015, the European Union financed two major research projects called Ponte and XF Actors.
Those projects of the program Horizon 2020, funded by the European Commission, are multidisciplinary projects where scientists from different disciplines, including plant pathologists, entomologists, epidemiologists, and very important social scientists and economists, work together to address the problem of Xylella Fastidiosa outbreaks in Europe. As the COVID-19 situation illustrates quite well, epidemics are complex and need the collaboration and interaction of different disciplines working together.
Thanks to the results of the EU-funded projects, today scientists have a much better understanding of their enemy and can propose low-impact measures to contain the pathogen. They've suggested techniques to control the population of the meadow spittlebug, which is the main vector of Xylella Fastidiosa in Europe. These are techniques based on key findings related to the insect's feeding behaviour, life cycle, and the mating vibrations that it emits. Another piece of good news is that automated surveillance and monitoring through remote sensing is now closer than ever to becoming a real possibility. The scientists are also coming up with new insights that shed light as to how the host plants can counteract the infections. Some of those far-reaching findings for research into Xylella Fastidiosa provided the scientific basis for a new set of EU measures adopted in 2020 and for common diagnostic procedures adopted by all EU member states.
The role of EFSA is to give advice based on science to inform the European Union policymakers and laws. Especially in the case of Xylella Fastidiosa, EFSA advice has grown in accuracy thanks to the essential contribution of researchers. On this basis, the European Union proposed new measures to counteract the spread of this pest.
Xylella Fastidiosa is still an issue in Europe, but the Ponte and XF Actors projects mark the beginning of a new era for evidence-based policymaking relating to plant pathogens. The projects also help scientists with expertise in plant health carve out a new role for themselves in the public debate.